It's Bill again, and thanks for joining us on this exploration of gravity. This discovery came as a result of my friend Alex asking an often dismissed question. That question was, what can be done with the energies in a quantum mechanical constrained degree of freedom? That question led to answers that led the way to gravity. My hope is that this video will allow everyone to embark on the same journey to the discovery of gravity and feel the awe-inspiring beauty of nature. So we begin with Maxwell's demon. Max is in a room full of gas, and there are particles with a range of speeds all moving in different directions. This activity averages into a temperature and pressure. Max tries to reduce entropy in the box so that all the hot particles are on the right side. He measures particles that happen by and opens the door only for hot particles. It seems he can separate hot from cold for free, and that seems to violate entropy. However, there is a cost to measurement, and that will create more heat on the left side. Then the left and the right side will equalize again, all because of the cost of energy Max has to spend on the cool side of the box to perform a measurement. The price of measurement can be paid in the form of a photon or even in the form of a bit of gravity, as we soon shall see. So how to find the energy cost for measurement? How much does Maxwell's demon have to pay to measure a spin of entangled particles on an event horizon 1 kilometer black hole? Now this will take a few steps. Step 1, find the total gravitational energy of that black hole and divide by the total number of Planck areas on the horizon to get a per Planck area of gravitational energy. Step 2, find the Hawking temperature of that given black hole. Step 3, find the amount of energy Maxwell's demon has to pay to measure the spin state of a particle by plugging in the Hawking temperature into the Landauer limit and report that value in joules. Check both values and see if the amount of energy Maxwell's demon has to pay, the Landauer limit energy, is the same value for the gravity bit. So first we're going to find the gravitational energy per Planck area. And we use the Schwarzschild metric, and we find that it's 6.735 times 10 to the 29 kilograms. We then use equals mc squared, calculate the total energy, which is 6.0736 times 10 to the 46 joules. Now we're going to take that entire energy value, 10 to the 46 joules, and we're going to divide it by the number of Planck areas on that black hole. And what we find is the gravity per Planck area from general relativity is 1.261 times 10 to the negative 30 joules. Step 3, we're going to find the Landauer limit at Hawking temperature. So we're going to find out how much Maxwell's demon has to pay to measure entangled pair by finding the Hawking temperature. The Hawking temperature is the temperature black holes emit as entropy, and black holes are usually very cold. Then we enter the Hawking temperature into the Landauer limit equation. This will tell us how much energy is required to erase a given quantum bit, which is the same amount of energy contained within that quantum bit. You can think of entangled particles as quantum bits. We use Hawking temperature because it flattens all the kinetic energy of the particles interacting on a black hole event horizon surface, and it leaves only the value of the bit itself, which is the minimum energy needed to measure a particle's spin state. And what we find when we enter Hawking temperature into the Landauer limit formula is 1.74 times 10 to the negative 30 joules. Now we're going to compare the results to see if there's a connection. From GR, general relativity, we got 1.261 times 10 to the negative 30 joules. We use the quantum mechanical way by using Landauer limit at Hawking temperature, we got 1.74 times 10 to the negative 30 joules. This is a difference factor of 0.724. This is nearly, looks like an emission process. It's actually very close to 1 divided by natural log 4, which indicates a 4-bit quantum system. but it looks like kind of like an emission process, and that's why Landauer is a little bit higher than the general relativity number. But now we have enough information so Maxwell's demon can go to the horizon and measure an actual entanglement in process and see how the magic happens. Max decided to measure the spin of entangled particles A and B. Now Max does not know the spin of either particle because the particles are in a superposition, both up and down spin states. Max must perform a measurement to reveal the spin. Both A and B have a 50% chance for an up spin and 50% chance for a down spin. Both A and B have up and down bits. So there are 4 bits in a 2-bit system, and the bits are up, down, 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 up, up, down, up. You can think of these bits almost like computer bits. A 0 or a 1 is kind of like an up or a down. Because A and B are entangled, their revealed spin states must be opposite. This means down, down, and up, up must be expended in some way. Before Max measures A, he looks at the matter particles closely and finds a bridge of entangled energy, the energy shown in black. And that energy connects A and B, so the first one to be measured will handle the spin resolution, so that the spins will always be opposite. Once the first particle is measured, the entanglement energy is used to obtain the gravitational energy to resolve spin. Step 1. Max measures A, the spin of A, and finds up. Because the particles were entangled, up, up, and down, down are forbidden. Think of it like how meshed gears have to rotate in opposite directions. If one gear is rotating clockwise, then the other gear must be turning counterclockwise. It's conservation of angular momentum. Step 2. The entanglement energy, in this case, turns into a wormhole-like object at 1.74 times 10 to the negative 30 joules, so that A and B spins will interact briefly, so their spin states will be opposite, just like the example of the gears. Max notices something amazing. He sees that the entanglement energy is relative only between A and B. Nobody else can see this energy, but that energy is what potentiates A and B with gravitational and Hawking radiation energy. Max realizes that if he had measured A and found down instead of up, the entanglement energy would generate the wormhole-like object. Max sees it's not really a wormhole, not quite a tunnel. Max still can't figure out yet, but Max will get to the bottom of this mystery. Step 3. The wormhole energy only exists long enough for A's spin to affect B's spin, and then it's gone. The energy from that wormhole-like object spreads an expanding bubble and is what causes the gravity at the energy level of 1.74 times 10 to the negative 30 joules per entanglement. Max wants to make sure he got his money's worth. He was told entanglement always shows opposite results no matter which particle is measured first. Max measures the second particle of the pair B and finds down. And then B's entanglement energy portion is emitted as a Hawking photon at Max's energy cost of 1.74 times 10 to the negative 30 joules, the same energy the wormhole-like object was. This time Max is at a 100-kilometer radius black hole, and he wants to check out how things work here. For one, he notices that the larger black hole has lower Hawking temperature and therefore a lower cost for Max to measure. Max is excited. It costs him 1/100th of the amount of energy to do the exact same kind of measurements as he was doing on the 1-kilometer black hole. Step 2, the wormhole-like object's energy is 100 times lower than the 1-kilometer black hole, but it's still enough to form an event horizon. The energy from emission of that wormhole-like object spreads in what causes the gravity that shows in general relativity as 1.261 times 10 to the negative 30 joules per entanglement. Step 3. A's upspin makes sure B's will be down. That caused A to break its entangled state, so the next time A is measured, it will again be random. but B is all ready to go with the right answer. Step 4. When Max measured B's spin and saw down, B's unused portion of the entanglement energy becomes the Hawking photon at 1.74 times 10 to the negative 32 joules. Max realized something. Even if particles A and B are light years apart, they can still correlate their spins instantly. How does this happen? Max saw that wormholes really aren't tunnels. Max has heard that there's a distant holographic particle horizon that may contain the reason why. Now Max has to play sleuth and look for something that might aid in the translation of particle spin information across vast distances. Some structure that may allow instant causal contact between entangled particles in spite of being billions of light years apart in 3D space. Something about the way the holograms work seems to point to an answer. Max had to look all the way to the cosmic event horizon, where all particles are sort of smeared holographically, encoded is a better word, equally across the entire horizon. Max can see pieces of A and B everywhere on the horizon in a holographic format. Particles A and B are encoded equally in a holographic way over the entire 2D spherical area of the horizon, billions of light years away. Even if particles A and B are billions of light years apart in 3D space, on the cosmic holographic horizon, our particles are actually right next to each other. A and B are entangled and share a common wave function, which you can think of sort of as an address where you can find particles A and B in holographic space. If you could look at a piece of a holographic structure of a particle on the cosmic horizon up very close, it would look very similar to how a hologram looks under a microscope. It's complicated, looks almost random, and not representative of the image you see at a distance. Holograms encode 3D information onto a 2D surface, with every element of 3D space being encoded everywhere across that surface in a 2D holographic format. That is why you can cut a hologram in half and get two identical full images, but at lower resolution. Entangled pair A and B are encoded in similar ways as objects in a hologram are encoded. It's the relations between the holographic elements that causes objects to emerge in 3D space. The holographic horizon gravitates things out of the observable universe and is the size it is from all the objects that cross the horizon. Their departure energy was captured and encoded as gravity, 1 bit per particle spin information. That distant gravity is then projected locally as needed, and the horizon shrinks. Max now measures the entire sequence of entangled pair in 3D space, but this time from his relative holographic horizon, a feat we can't do. When A can't translate its spin to B because A and B are at different spatial addresses yet have the same quantum address, then A's unused wave function encodes as a bit of gravity across the entire surface as an expression of causal uncertainty, which makes A and B local. So A's spin can properly affect B's spin. That gravity bit allows each holographic element of A to interact with each holographic element of B across the entire horizon. Once the connection is made, the uncertainty is resolved, and then the gravity bit's re-encoded as spin, and then B will have the opposite spin of A. Max now sees that there is no wormhole. The holographic encoding of the cosmic horizon is what allows the connection of two distant points in space because the entangled particles are physically right next to each other on the holographic horizon. Holographic encoding from an information-dense distant horizon provides the necessary structure for spooky action at a distance. So here we can see that at the cosmic horizon, we have 1.338 times 10 to the negative 53 joules, and it gets projected down 1.3 times 10 to the 23 orders of magnitude, which gives us our 1.74 times 10 to the negative 30 joules of gravity locally on that black hole event horizon. Here's an entropy formula for the entire universe. Delta S cosmic plus delta S local equals 0. So entropy for gravity on a cosmic horizon. You could see here that we have a bunch of particles that are leaving the cosmic horizon, and each particle that crosses adds 1 Planck area of negative energy. So as a local particle is close to crossing the cosmic event horizon, its spin information is redshifted, which shows as a reduction in energy, or S local equals -1. The redshift increases until it becomes infinite, and the apparent spin energy appears to be 0. The cosmic horizon encodes the redshifted energy as a bit of negative energy on that horizon, which expands the cosmic horizon by +1 unit. Energy appears to be 0 locally, so the cosmic holographic horizon encodes the entire amount of redshifted energy as negative energy. Now the horizon has negative energy bits ready to emit gravity locally to resolve entangled matter particle spin measurement. Most of the gravity bits on the cosmic horizon came from the Big Bang producing virtual particles that turned into cosmic horizon surface area 13.8 billion light years away, which gave us space. Now, this is the entropy formula reversing for gravity emission. In this case, the cosmic horizon will shrink by 1 unit, and then local will add 1 unit of entropy. So the cosmic horizon erases 1 Planck area, -1, to correlate A and B's spin, which breaks the gravity's bit entanglement with the cosmic horizon so that it emerges locally, and B's measurement emits 1 Hawking photon +1 to conserve total energy of the now slightly smaller A's observable universe. Think of the Hawking photon as a receipt for an erased Planck area, proof that a gravity emission occurred. B's observable universe didn't resolve spin's disentanglement measurement cycle because A was measured first, but B will get its opportunity in short order. The universe uses a ledger-based, decentralized processing, event-driven peer-to-peer communication protocol that is strikingly similar to blockchain. Now, Max realizes that the way gravity emerges, we can explain how it emerges on Earth. Earth emits gravity at varying strengths as particles share spin entanglement. The highest gravity is at the core of our planet. It's at 1.261 times 10 to the negative 23 joules. And as you come closer to the surface, the energy drops because the curvature goes down. And when you get to the surface of the planet, you get about 4 times 10 to the negative 34 joules per gravity emission. So as curvature goes down, the amount of energy Max has to pay to resolve spin states also goes down. Thank you so much for joining me and Max on how gravity works. This is a relatively new discovery, so I'd really like if you have any ideas for improvements or if you see any problems, please let us know. And I think together we can develop this into a full-scale model. Thank you very much for watching, and we'll talk to you later. Bye.